GitHub Copilot was built with developers in mind. The marketing talks about auto-completing functions, generating boilerplate, and speeding up feature development. What the marketing does not talk about, because most of its audience is developers, is how useful Copilot is for QA engineers specifically. Writing test code is one of the highest value use cases for any AI code assistant, and the reason is simple. Tests are structured, repetitive, pattern-heavy, and tedious to write from scratch. You write the same kinds of assertions over and over. You set up the same kinds of fixtures and mocks. You handle the same kinds of edge cases across dozens of different functions. Copilot is genuinely good at recognizing and completing all of those patterns. In this episode, we are going to look at exactly how to use Copilot in your QA workflow. Not the generic autocomplete features everyone already knows about, but the specific techniques that make Copilot useful when you are writing test suites, parameterizing test cases, mocking dependencies, and asserting against complex outputs. We will also cover the two areas where you need to be careful, because Copilot can give you false confidence if you accept its suggestions without the right review habits. By the end of this episode, you will have a clear and practical picture of where Copilot saves you real time and where you need to apply your own judgment. Let's get into it. Copilot works by predicting what you are about to type based on the context of your file. That context includes the code above and below your cursor, the name of the file you are in, the imports at the top, and any comments you have written nearby. For QA engineers, this means a few things that are worth understanding before you start. First, the name and structure of your test file matters more than you might think. A file named user_auth_test.py or test_user_authentication.py gives Copilot much better context than test_miscellaneous.py or tests.py. The file name is part of the context window, and a descriptive name immediately tells Copilot what domain it is working in. Second, descriptive test function names are your primary way of steering the suggestions you get. A function named test_login_fails_with_invalid_password is going to get a far more relevant and specific suggestion than test_case_1 or test_login. The name is the prompt. Make it count. Third, and most importantly, comments are your most powerful tool for directing Copilot. If you write a comment describing exactly what you want to test before you write the function, Copilot will use that comment as its primary instruction. This is the core workflow for using Copilot effectively in test writing. Describe what you want in plain language as a comment. Let Copilot generate the function body. Review it carefully. Accept what is right, correct what is wrong, and move to the next test. You are not necessarily typing less overall. You are reviewing instead of writing from scratch, which is significantly faster once you build the habit. Let's talk about three specific testing patterns where Copilot is particularly strong. The first is parameterized tests. Writing a parameterized test by hand means defining your test dataset, structuring your decorator or fixture correctly, and making sure every important case is covered. Copilot is excellent at this pattern. If you have one or two test cases already written in a parameterized block, Copilot will often extend it with a full set of boundary cases, negative cases, and common edge cases automatically. The suggestion is not always complete, but the scaffold is usually solid and saves significant time. Always review what it adds, but in my experience the parameterized test pattern is where Copilot delivers the most consistent value. The second pattern is mock setup. Mocking external dependencies is one of the most tedious parts of writing unit tests. There is a lot of boilerplate, the syntax varies by framework, and it is easy to set up the mock incorrectly in ways that do not immediately surface as test failures. Copilot has seen enough testing code across enough frameworks to recognize common patterns for mocking HTTP clients, database connections, file systems, and third-party APIs. It is not always right about the specifics of your system, but it usually gets the structure and the syntax correct, which is the hard part. The third pattern is assertion completeness. After you write the action step in a test, Copilot will often suggest a fuller set of assertions than you would write from memory. It knows to check status codes, response bodies, state changes, and side effects together. The pattern recognition is genuinely useful here. Here is a practical demonstration of the comment-driven workflow so you can see exactly what this looks like in practice. Suppose you are writing tests for a REST endpoint that creates a new user account. You open your test file, which already has your imports and your test client fixture at the top. You write a comment, test that post to /users with valid payload returns 201 and the response body contains the new user's ID and email. Copilot generates the full test function. It builds a sample payload with a name, email, and password, makes the post call using your test client, asserts the status code is 201, and checks that the response JSON includes an ID field and an email field. You review it. The structure is right. You might need to adjust the field name if your API returns user_ID instead of ID, or if the email field is nested differently in your response. You fix those things and move on. Next comment. Test that post to /users with a duplicate email returns 409 and includes an error message in the response. Copilot generates that test too. It reuses the same payload structure, makes the post call twice to create the duplicate condition, and asserts the 409 status in the presence of an error or message field. You review, adjust the assertion to match your API's actual error response format, and you are done. 2 complete tests in under 3 minutes. The habit scales quickly across a full test suite. The more you use it this way, the faster the review step becomes. There are 2 areas where you need to be genuinely careful with Copilot in a QA context, and both of them have the potential to give you false confidence if you are not paying attention. The first is test completeness. Copilot generates tests based on patterns it has seen in public code. It is very good at the obvious cases, the happy path, the basic negative cases, the common error conditions. It is much less reliable at the business logic specific edge cases that only someone who has actually read your requirements document or talked to your product team would know to test. If your system has an unusual permission model, a non-standard business rule, or a domain-specific edge case, Copilot will not know about it. Always treat Copilot's output as a starting point, not a finished product. After it generates a test suite for a feature, take 60 seconds and ask yourself what it missed. That question, what did the AI not think to test, is one of your most important QA skills when working alongside these tools. The second area is test correctness. Copilot can write a test that looks right syntactically, runs without error, and tests the wrong thing entirely. A test that always passes regardless of the code's behavior is worse than no test at all, because it gives you false confidence in coverage you do not actually have. After accepting any Copilot suggestion for a test, deliberately verify that the test actually fails when it should. Introduce a small intentional bug into the function under test and run the test. If it still passes, the assertion is wrong. Fix it before you commit. GitHub Copilot is not magic, and it is not a replacement for a QA engineer who understands the system under test. But it is genuinely fast, it knows common testing patterns deeply, and it removes the friction of writing boilerplate test code from scratch. Used correctly, with descriptive file and function names, comment-driven prompts, and careful review habits, it can meaningfully increase how much test coverage you produce in a given sprint. The key habits to build are simple and worth repeating. Name your test files and functions descriptively. Use comments to steer Copilot suggestions before you write any code. Always verify that tests fail when the code is broken before you commit them. And always ask yourself what the AI did not think to test, because that question is where your expertise as a QA engineer matters most. Consistency with these habits is what separates engineers who get real lasting value from Copilot and those who use it occasionally and find the results underwhelming. In the next episode, we are going to go beyond Copilot and look at how to use standalone large language models to generate test cases directly from requirements documents and user stories. That workflow does not require any IDE integration and it works regardless of what language or framework you are using. Subscribe so you do not miss it, and share this with a QA engineer on your team who is still writing every test by hand.